Hello everyone, my name is Greg and today I would like to walk you through 5 questions from the latest Aircraft General Knowledge exam seen in the last 30 days across all authorities. Topic for today is pressurization and air conditioning systems. Question number 1. During level cruising flight, an airplane experiences a malfunction of the pressure controller. If the cabin vertical speed indicator reads 200 feet per minute rate of descent, the differential pressure will rise to its maximum value, thus causing the safety relief valves to open. A descent must be initiated to prevent the oxygen mask dropping when the cabin altitude reaches 14,000 feet. The aircraft has to climb to a higher flight level in order to reduce the cabin altitude to its initial value. The crew has to intermittently cut off the incoming airflow in order to maintain a zero cabin altitude. The cabin vertical speed indicator works on the same principle as aircraft's vertical speed indicator. It senses the rate of change in pressure. If the pressure increases, it indicates rate of descent. If the pressure decreases, rate of climb. So, the rate of descent of 200 feet per minute indicated on cabin VSI means that the pressure in the cabin is increasing. At the same time, since the aircraft in question is cruising in a level flight, the outside atmospheric pressure is constant. Therefore, the differential pressure is constantly increasing. When it reaches the maximum value, which is usually around 8-9 psi, the safety valves open to prevent the overstressing the aircraft structure. So the correct answer is answer number 1. The differential pressure will rise to its maximum value, thus causing the safety relief valves to open. And this one is correct. Question number 2. Please refer to the annex to answer this question. Because of a crack in the windscreen, an aircraft with a standard cabin altitude in the cruise of 8,000 feet is limited to a differential pressure of 4.5 psi. What is the maximum pressure altitude at which the aircraft can fly? Okay, we know that we are limited to a differential pressure of 4.5 psi. What we need to do first is to check how much psi we have in our cabin. To do so, let's open the table in the annex. Okay, as you can see, here on the left, we have the pressure altitude. And this column here is a psi. Let's go down to find that at 8,000 feet, here, which is our cabin altitude, the pressure is equal to 10.92 psi. Now, to find out our max cruising level, we have to subtract 4.5 from 10.92 and then check the corresponding pressure altitude in the table. So 10.92 minus 4.5 gives us 6.42. That means that we must find the pressure altitude with a corresponding psi not lower than 6.42. Going slightly up, we can find that 6.47, which corresponds to 21,000 feet, is the last acceptable psi. As we can see, for 22,000 feet, the corresponding psi is 6.21, which is already lower than 6.42. Therefore, we cannot accept this one as it would exceed our maximum pressure differential of 4.5 psi. So, the correct answer is 21,000 feet, answer number 1. And this one is correct. Question number 3. Assuming cabin pressure decreases, the cabin rate of climb indicator should indicate a rate of descent dependent upon the cabin differential pressure, a rate of climb, a rate of descent of approximately 300 feet per minute, or 0. Cabin VS indicator works in the same way as the vertical speed indicator on the primary flight display. Whenever pressure in the cabin decreases, the cabin vertical speed indicator shows us a rate of climb. When pressure in the cabin increases, it indicates rate of descent. I know that in the beginning, this type of question might be confusing. So if you have any doubts, just think about what happens with atmospheric pressure during climb or descent. So the correct answer is answer number 2. When cabin pressure decreases, cabin vertical speed indicator should indicate a rate of climb. And this is the correct answer. Question number 4. Cabin pressurization is maintained by controlling the negative relief valve, regulating the bleed air supply to the cabin, a special blower on the accessory section of the air conditioning system, or controlling the outflow valves. This question asks for what I believe is the most basic principle of the pressurization. The cabin pressurization is always controlled by position of outflow valves and not by air supply to the cabin. Air supply to the cabin, or pack flow in other words, depends solely on passenger number or external conditions. For example, on A320, on very humid, warm day, we would say it's a high pack flow that would give us 120% of a normal flow. Therefore, the correct will be answer number 4. Cabin pressurization is maintained by controlling the outflow valves. And this answer is also correct. The last 5th question. Assuming cabin differential pressure has reached the required value in normal flight conditions, if flight altitude is maintained, the pressurization system ceases to function until leakage reduces the pressure, there will be a constant air mass flow through the cabin, the outflow valves will move to the fully open position, the pressurization system must be controlled manually. It's worth to remember that there is always a constant air mass flow through the cabin, and it depends only on the pack flow setting, regardless of the flight level we fly on. Now, the pressurization is controlled by the position of the outflow valve. As you can imagine, the fully closed outflow valve would create an overpressure and subsequent opening of the safety valves. Fully open outflow valve, on the other hand, would cause a depressurization of the aircraft. In normal flight conditions, the operation of the outflow valve is fully automated and does not require any input from the crew. Now, even though the wording of this question is not the greatest one, the only correct answer is answer number 2. There will be a constant air mass flow through the cabin. And this one is also correct. Alright guys, thank you very much for today. I hope you enjoyed and see you next time.